Hello, everyone. Our work is facing great challenges and at one time also great opportunities. Build the Future is a series of digital talks about research and how research can address these challenges and opportunities. Today, you'll see we have a different set. We are broadcasting from Edu Cafe, which is an experimental teaching room here at Politecnico di Milano. I am Gianluca Valenti. I am very pleased to welcome you to today's talk about archaeoastronomy. And here we have Professor Giulio Magli, who is going to be today's speaker. And also, I see on the screen, we have Susanna Sancassani, who is going to moderate today's talk. So, Susanna, ciao.
Hi.
And the floor is all yours.
Ciao, hi, everybody. Thank you so much. So we are very, very happy today to be here with Professor Giulio Magli. Professor Giulio Magli is the director of the Department of Mathematics here at Politecnico di Milano, but he is above all an astrophysicist and a world-famous archaeoastronomer. What's an archaeoastronomer? He is a scientist working on the relationship between the architecture of ancient cultures and the sky. And today, the 21st of June, is a very, very special day. Let's discover why, and let's listen to a lot of stories the stones can tell us, thanks to Professor Giulio Magli. The floor is yours.
Thank you, Gianluca. Thank you, Susanna. Thank you very much. Very happy to be here today because this is a very good place to discuss about our research lines, to present research lines in Politecnico Milano, and also to show opportunities of study and also of joining these research lines for second degree students and PhD students. So the science I'm going to speak about today is called archaeoastronomy. It's a relatively new science. I've been working, actually field working in archaeoastronomy since the last 20 years or so. I'm teaching archaeoastronomy here since 10 years or so. And what I usually say about this science is that it is the science of stars and stones. So I would like to give you some flavor, some idea today of why we like to call this science the science of stars and stones. The best way to speak about archaeoastronomy is to start from astronomical heritage. Astronomical heritage, what do I mean by astronomical heritage? Astronomical heritage essentially is really most of our cultural heritage in the world. It's plenty of monuments, even cities. Here we see the Machu Picchu citadel of the Incas in Peru. All these sites have astronomical connections. So astronomical heritage is a set of heritage which has astronomical connections. I will show you in a while what an astronomical connection is, but just to collect a few examples. So this is a Greek pyramid we're going to speak about at the end of the talk today. And this is Angkor Wat in Cambodia, where I've been working as well in field work, the most huge temple of humanity, Angkor Wat. And we're going to speak a bit about China as well today. So this is, of course, is the Hall of Supreme Harmony, Forbidden City in Beijing. And since we are in Italy, just two examples from Italy. This is the Pantheon in Rome, and this other one is the Temple of Concordia in Akragas, Sicily. So all of these, a lot more, are monuments belonging to astronomical heritage. What does I mean? I mean that hierophanies occur in such monuments. What is a hierophany? Hierophany is a manifestation of the sacred. It's a connection between the design of a monument, the project of a monument, and a phenomenon which occurs in the heavens. Typically the sun, but not necessarily the sun, but typically the sun. So it is a sort of machine which connects the built feature with the sky, the heavens. And of course, it has a sacred content, a religious content, which is the aim of archaeoastronomy to analyze. A few examples. Here is the Concordia temple in Akragas. The sun rises in alignment at the spring equinox, a picture made by our group. This is Angkor Wat, I've shown before. This is the sun which climbs up the central tower of the temple at the spring equinox. Here we are in a tropical zone, so the trajectory of the sun are very steep, so it goes almost vertically behind the central tower. This is the Pantheon on the 21 of April, the day of foundation of Rome, where this beautiful hierophany of the sun hitting the door of the Pantheon at midday, and showing in a sense, the power of Rome in the day of foundation of Rome. And this is perhaps one of the most famous hierophanies in the world, the light and shadow plummet serpent, which can be seen on the Castillo pyramid in Chichen Itza, Yucatan, Mexico. It was built by the Mayas. So just to show you a few of these beautiful phenomena which occur, which an archaeoastronomer may have the chance to study and to assist as well. From the technical point of view, the instrument of archaeoastronomy is the study of the astronomical alignments. To show you what an astronomical alignment is, I will show you Stonehenge, which is essentially the place where all this was born in the 60s of the last century. And Stonehenge, this is a Neolithic monument constructed in the third millennium BC. The megalithic phase you are seeing now is about 2400 BC. Stonehenge has an axis. This axis goes to the horizon. It crosses one huge stone. Actually, there were two stones. It was a sort of portal for the sun. And when you go to the horizon, you can check that this direction goes to the point when the sun rises at the summer solstice. So the summer solstice is not a chance, is a choice for the day of this talk, also for other reasons, but this is the first reason. And we can actually see the sun rising in alignment with the axis of Stonehenge at the summer solstice. These are very famous images. Today, actually, we think that the phenomenon was rather seen in the opposite, on the other way around. This is a picture by my friend Clive Ruggles, which shows the sun setting into the monument at the winter solstice. Due to the flat horizon, both the phenomena occur, and we think that Stonehenge was rather connected with the world of the dead, or with afterlife, so rather connected to the winter solstice in the Neolithic Europe. But what counts is that you can measure a monument and you can analyze the significance, if any, of the astronomical alignments. So from here, you can start to construct a complete science, which settled only, I think, in the last 40 years, not more. Why this science is so delicate? Because archaeoastronomy is a discipline in between. In between what? In between archaeology, architecture, and exact science. So you must work always from a cross-disciplinary point of view. You can use whatever scientific tools you want. There are so many tools today that we can use. Topographic relief, for instance, laser relief and so on. Satellite imagery, digital sky globe, because you need to reconstruct the sky in ancient times, statistical analysis, and so on. So here we have a look to the technical part of archaeoastronomy. This is a rather old-fashioned study we made of the Temple of Sicily with a standard theodolite. Today there are more fashionable instruments, but just to show you, when you work, you need to point the theodolite at the sun at midday. Maybe it can be hot, and so on. But then you can use satellite imagery. This is an example from China, which will be discussed briefly in the second part of visual connection between pyramids in China. And you must reconstruct the sky. Why you must reconstruct the sky? Well, if you look at this image, this is a sort of provocation. You see that this is the North Celestial Zone, the zone of the North Celestial Pole, but you will not recognize it because you see that Polaris, which is our pole star, is in the Ursa Minor constellation, and you see it's very far from the North Celestial Pole. The reason is a physical phenomenon called precession that changes the declination of stars, in particular the position of the North Celestial Pole with respect to the stars. So an exercise could be to understand when the North Celestial Pole was in this way. And of course, statistical analysis is a very simple example of histograms. You can use also more complex instruments. But this is not enough. This is only half of the story. Because you do need whatever you have from the humanities as well. Historical text, excavation data, landscape archaeology, cognitive archaeology at most. So you want to understand the way of thinking of people. You don't you are not satisfied if you have an astronomical alignment, if you don't show that the astronomical alignment does not occur by chance. And this is the origin of most of what I call, trash bin archaeoastronomy, and which you can find a lot of that in the web. Usually errors, which propagate very fast, by the way, especially on the web, come from the missing part, from the part of humanities. So the part of dating, of archaeological remains, and so on. So you must work in this two direction together. If you are able to do that, then you have a science which has huge potentialities, at least in my view. Why? Because the knowledge of celestial cycles was a milestone for power. Understanding the relationship between astronomy and monumental architecture means a better understanding of religion and power in ancient cultures. Why? Because any people having the power, let's say shamans or kings or pharaohs of the Chinese emperor, whatever, connected their power with the heavens. It was a simple way, a very effective way to justify power. I will show you two examples which are the milestone for the two case studies I'm going to speak in the second part. The first comes from China. This is Tijan. Tijan is the god of the northern stars. The area of the northern stars, the so-called purple enclosure, was a place where the images of the Chinese emperor's family was living in the sky. So Tijan is a sort of celestial image of the living emperor on Earth. And look, where is he? He is in the chariot, and this chariot very clearly is the Big Dipper. So it has the standard form, the same we use in this case, of the Big Dipper. So he lives in a chariot which is actually the Big Dipper. So it's very clear connection between the power on Earth, power on the heavens, and architecture as well, because the Forbidden City, the place where the Chinese emperor was living, was conceived as an image of the North Celestial enclosure. The other example is another case study, in a sense. It's a complete civilization, 3,000 years of civilization in Egypt. This, to me, is a relief which shows in a fantastic way all these connections, because we have the pharaoh. The pharaoh considers himself a god, so he is actually a living god, Horus. In front of him we have Sishat. Sishat is the goddess of knowledge. The head of Sishat as a star symbol which associates her with the knowledge of astronomy in particular. What are they doing? They are stretching the cord. What does it mean, stretching the cord? They are setting on the ground the perimeter of a new temple. So the foundation of architecture is a sacred act. Foundation of architecture is connected with the fact that the architecture itself will be sacred, will be a temple. So we have the gods, we have the power, because Pharaoh is a god by the temporal power which interests to him. We have the ceremony of projecting architecture, and we do have the sky, because if we look at the hieroglyphs in the wall, we see that the hieroglyph says that they are looking at the northern stars. So they are orienting the temple, looking at the northern stars. So you see, it is a complex mix of connections which can be studied, can be addressed by archaeoastronomy. But let me say that at least recently, archaeoastronomy has acquired also another, to me important, I think it is important, role. This role is related to the valorization of cultural heritage and sustainability of cultural heritage. Why? Most of the astronomical and also topographical alignments, because if you have two monuments that speak each other, we will see example in a while, and they were built to speak each other in a symbolic way, saying, for instance, this is the temple of my father, I want to align with it. Then you must use the techniques of archaeoastronomy as well. So astronomical and topographical alignments, many of these are still effective today. What does it mean that they are still effective today? You can experience them today. You can actually go, this evening we could perhaps pick up a plane and go to Giza to see something today on the summer solstice, which was projected 4,500 BC. 4,500 years ago. So it is a key to valorization. You can say this monument has an astronomical value, you can enjoy the astronomical value going the correct day. And a tool for sustainable development. Why? Because world is changing. Ancient monuments are relics inside the changing world. And you can build a skyscraper, or you can exit from the buffer zone of UNESCO and have a new quarter of a town and so on. But if you do that, you could interrupt the alignments, because the alignments are not a matter of the UNESCO buffer, the alignments are a matter of horizon. So to protect the value, the astronomical value, it's also a matter of sustainability of such important monuments. This has recently been recognized by UNESCO with the Astronomy and World Heritage Initiative, to which I contributed as well. You can find these two volumes for free on the web easily, and the aim of this initiative is to enhance the valorization of cultural heritage from the point of view of astronomy, or archaeoastronomy, or astronomy. I'll show you two recent very important cases. This is the 13 towers of Chanquillo in Peru, which acts as a true observatory of the 2nd century AD or something, which has been, is going to be hopefully recognized by UNESCO. The other example has been recognized recently, is the cave of Risco Caído, which is in the Canarian island, and this has been inscribed in the UNESCO list recently, also for its astronomical value. So I think that this is an added content of archaeoastronomy, which is going to become more and more important in the next years. So the choice I've made to show you how this discipline works is to discuss two case studies on which I've worked by myself on field, and which to me are very clear in their astronomical and topographical, symbolic topographical content. The first one is the case of the pyramids of the Han Dynasty. So we are going in China. Pyramids in China, so it may look strange, but I will explain in a while why I'm speaking of pyramids of China. From the moment, let's speak about Han mausoleums, so the tombs of the Han emperors. We are in the Han dynasty, so it's about 200 BC up to 200 AD, but the monuments we are going to speak about are the Western Han dynasty, which is the first 2 centuries BC. So we are immediately after the foundation, the true unification and foundation of the imperial power in China, which was made by Emperor Qin, the famous emperor of the terracotta warriors. The capital of the Qin dynasty is located essentially in the area of today's Xi'an. So here we are seeing a satellite image of the area of Xi'an, which is the town, and to the north of the town we see the carts of the river Wei. To the right of the modern Xi'an is the mausoleum of the terracotta warriors, so the mausoleum of the Qin emperor. The Han emperors make a different choice and go to the north of the town and construct their mausoleums in the area which is called today Xixian. It is the area between Xi'an and Shenyang, where the airport is, and it is an area of very rapid development. By the way, the Polytechnic of Milan has a building in the Jiaotong University, which is near Shenyang. The new place of Jiaotong University is near Shenyang. So in this area, which is today is fully of industries and new buildings and so on, you find these objects. What are they? I call them pyramid because they're actually mounds. They are earthen hills. But it's not just a matter to pick up earth and pull it there, because otherwise rains would have dilated them. So they're actually built. They are built with huge blocks, let's say in this way, of rammed earth. So this compacted earth added with straw with reduced humidity, and you build them. And they are very, very huge. They are still today more than 50 meters high and more than 200 meters side base. So these are the tombs of the Han emperors. Let's have a look at a few of them. And you see they dot the landscape to the north of Xi'an. Of course, these are all pictures that I've taken trying to avoid the veining buildings which are there. You see they form a very fascinating landscape. All of them are satellites, pyramids, which are for concubines, empresses, and so on. So there are more than 40 of these objects. Not even one emperor tomb has been opened, but there is one tomb which has the funerary pits opened, like the terracotta warriors. And what has been discovered today has been, by the way, musealized in a very beautiful museum projected by a friend of Polytechnic of Milano, with Professor Liu Kecheng. You see there are miniaturistic terracotta warriors, not only warriors, also animals and so kitchens and so on. So very, very nice funerary equipment, but not of the size of, which is life size essentially of the terracotta warriors. So what we can say about these monuments? This is a picture which I made from the top of the Gaozu pyramid. To the left we see a few of my Chinese students in Jiaotong. And you see there is a huge, actually twin pyramid to the horizon. And when you go to the top of the pyramid of the sun, of these two people, these two people are the emperor and the empress, so they are parents. When you go to the top of the pyramid of the sun, as we are looking here, you see a sign of two mountains. You see there are of course there are no mountains, it's completely flat. So the mountains you see are pyramids. And you align the base of the pyramid of the sun, you see another one here, more in the foreground, and the sign at the horizon. This sign is symbolic. It says I built here because I am their son, I am legitimated to rule. So this kind of connection is a topographical connection which can be discovered by archaeoastronomy and must be, in my view, maintained because it is part of the original project of these monuments. Another example is the picture I've shown you before. This is a connection between the pyramids of An Yanling, which is another pyramid with satellite ones. They form geometric connection. You see here very clearly that buildings are besieging the archaeological area at risk of making in danger the sustainability of the landscape, if not of the monuments, but of the landscape of the tombs. Very rapidly, what astronomy says about the An pyramids, well, there are two families. A very clear one is oriented to the cardinal points with high precision. The Chinese astronomers were very accurate, and you see these huge squares in the satellite images are the An pyramids, and the north is parallel to the side of the screen, so they are very perfectly oriented. But as you see here, but we discovered that there is another family. This family, let's call it skewed pyramids. The north remains on the side. So you see, these are huge complexes which are oriented some 15 degrees to the west of north. There is no doubt that there is no error here. It would be easy to say that the Chinese astronomers were making 15 degrees of error would be just crazy. So, so there must be a reason for this. And this made a lot, I don't know, but this made sort of rumor on international press because Polytechnic of Milan group discovers the skewed pyramids. In fact, they are not skewed, they are perfectly side-based square, but they are not oriented to the north. And so these are skewed pyramids which we discovered, and the explanation is astronomical. We're entering into details, but as I said before, there is a precession which moves the north-south pole, apparent movement of the north-south pole. So the pyramids which are to the north are to the true celestial north. The other probably are to the position of Polaris. In An times, Polaris was not coinciding with the north-south pole. The north-south pole was not coinciding with Polaris, so you have these two families. Speaking about archaeoastronomy of Egypt will take us perhaps 10 years, but so I just picked up one example, and this example is a thing which is going actually to occur in a few hours. So that's why I pick up this example. This example is what I call the horizon of Khufu. Horizon will be clear in a moment. Khufu is the pharaoh, this the builder, Cheops from the Greek, is the builder of the Great Pyramid in Giza. Giza is today a sort of outskirt of modern Cairo on the western side of the Nile floodplain. And you can discuss a bit about the date, but to fix ideas is 2550 BC. So the thing we are going to see were constructed more than 4,500 years ago. Let's go just for a while to the Giza plateau. It is a plateau because on the rocky steep over the Nile floodplain, so the pyramids were not flooded by the Nile. Today the Nile does not flood anymore, of course, because there is the Aswan Dam, but in ancient times all the Nile floodplain was flooded. So this is, by the way, the true key to the construction of the object we are going to see now, because the production of the state economics was overwhelming. And this was a true possibility to permit people to build the pyramids. The pyramids were not built by slaves, were not at all, were not built by peasants, not at all. They were built by specialized workers. And specialized workers were fed by the state. So the state was so healthy that they could afford huge, very huge state project. These projects are the tombs of the pharaohs. And the hugest one is the Great Pyramid of Khufu. Still today is I think the weightiest object ever built on planet Earth. It's about 8.5 million tons of stones, about 2,200,000 blocks of stones for a weight of 8 million and more. It's still today is about 146 meters high, 230 side base, and so on. So you can speak a lot about the accuracy and seriousness of the builders at Giza. This is the second pyramid, which is the tomb of the second son of Khufu. The first son, Jedefra, chose another place called Erush. And in front of the second pyramid, which is just a bit smaller, just a bit smaller of the Great Pyramid, but it is steeper, so it looks greater actually. You see, of course, the Sphinx, which is this famous statue, but it is built on a rock knoll. It is not a movable statue. That will be impossible. It is more than 50 meters length, the body of the lion. So it was sculpted from a rocky knoll. And the third pyramid of Giza, the Menkaura pyramid, is much smaller, but not less beautiful. It has a lot of details. For instance, it was partly cased in granite and so on. So let me just insist on the fact that these are monuments which were built by very serious people, and there is no mystery in the pyramids, but there are a lot of enigmas, and such enigmas are coming from the fact that they were very, very serious, and we must be serious as well when you study pyramids. For instance, here we see the north base of Khufu. It was perfectly, otherwise it was impossible to build it. And it was completely encased in whitish limestone. So the pyramids were shining in the sunlight before the casing was picked up in the Middle Age. So we see today the pyramids as sort of bare objects. There are no this white casing. And this is a southwest aerial image of Giza that shows the topography there. And this is a very famous topography because the pyramids align along 45 degrees diagonal, which you can see here. This has generated a lot of theories, rumors, and strange things. Actually, I do believe that the reason for the topographical structure of Giza is symbolic, but it has nothing to do with astronomy. It is rather a connection with the Temple of Heliopolis, which was the place where the cosmology of the ancient Egyptian, especially the Old Kingdom, was codified. So if you make the exercise to pick up Google Earth and prolongate this line, it will cross the area of the Heliopolis temple very precisely, although it is very, very far, more than 50 kilometers far. So they were very, very accurate surveyors. And in making surveys, they were using astronomy. This is the instrument they were using, called Merket, sort of cross fork, helped with an assistant. And they realized a very impressive accuracy. You see the accuracy in the orientation of the Great Pyramid. It's about 3 arc minutes. These are not degrees, they are arc minutes. So you pick up a degree, divide by 60, and pick up 3 parts. Think how small is such an angle and how small is such an error. If I would ask to my architecture students today to make such a small error, they will think I am mad, and they will probably be true, because it's an accuracy which today is unuseful. So we are going to close this talk, and there will be, I will need many hours to speak about the connection of Giza with the heavens, but I will show you just one. However, as an idea of list of what is there, let me show you the pyramid text that speak about the future afterlife of the pharaoh in the heavens. There are so many of these. First of all, the doors of the sky, which are open for the pharaoh. The imperishable stars wait for the pharaoh. Imperishable stars are the stars that do not set. So they are the stars near the North Celestial Pole, again, as in China. Then you have an image of Osiris in the sky, which is Orion. So another destination of the pharaoh is in the southern sky. Then you have Heliopolis, and the text says that all the family, a family which starts from the sun god Ra, because the pharaoh says it's a direct descent from the sun god Ra, starts in Heliopolis. That shows the topographical alignment. And finally, the pharaoh will join the sun god Ra. They will cross the sky together, united in the darkness, ready to rise again together. Where was this thing to happen? It was to happen in a place called Akhet. Akhet is usually translated as horizon. Okay, is translated as horizon, but it's a symbolic horizon. It's a place where the dead are prepared to join the heavens. So it's a place of transformation in Egyptian religion. Now we are going to see what happens today in Giza, and we are going to see that it was conceived to make an explicit realization of this phenomenon. We are looking west from the Sphinx Terrace, so we are looking to the main two pyramids of Giza. The Sphinx is in front of us. The Sphinx was called Orem Akhet, Horus in the Akhet, Horus in the horizon. Let's see why. The sun is going to set today. This picture was taken at the summer solstice, of course. And of course, the sun moves at the horizon during the year like a sort of red ball, which is going to set in different places in different days. But today, and the days near, of course, the sun is going to set precisely at the center between the two main pyramids. You see, this is the maximum of the phenomenon. The sun is just about to set and forms an image which is made by two mountains. These are artificial mountains, in fact, but two mountains and the sun in the center. Why I'm saying that this hierophany, and to me is perhaps the most spectacular hierophany ever discovered in archaeoastronomy. Maybe other can be discovered, but this one may be the most spectacular discovery. Because the name of the Khufu complex, each pyramid complex had a name. The name of the Khufu complex was precisely Akhet. The funerary complex of Khufu was called the Akhet of Khufu, the horizon of Khufu, and the hieroglyph that is translated Akhet is made by the sun between two mountains. So in a sense, sorry to repeat it again, but it's important, from 4,500 years, more than 4,500 years, every year at the summer solstice, the name of the Khufu complex, the fact that Khufu is going to join the heavens, is replicated. And to me, this image is perhaps also the best way to conclude this talk. Thank you very much.